Hello everyone. In this video, we will learn about the round-robin scheduling algorithm. Round-robin scheduling. This is similar to the first-come first-served scheduling, but preemption is added to enable the system to switch between the processes. A small unit of time called a time quantum or time slice is defined here. A time quantum is generally from 10 to 100 milliseconds in length. After this time has elapsed, the process is preempted and added to the end of the ready queue. Let us see a problem here in the round robin scheduling. There are three processes given and the corresponding burst times are also listed. The time quantum defined here is 4 milliseconds, which means each process will be given a chance to execute for 4 milliseconds, after which if any burst time is remaining, it will be added to the end of the ready queue. This is the Gantt chart for the given problem. That is P1 will get executed for 4 milliseconds. So out of the burst time 24, still 20 more milliseconds are pending. Then the chance is given to P2. Though the quantum is 4, the burst time of P2 is 3. P2 will get executed for 3 milliseconds, so 4 to 7. Then the chance is given to P3. It will start at 7 and it will execute till 10. Now out of the three processes, P2 and P3 have completed and P1 is still remaining with the burst time 20. So P1 is the only process available. It will get executed for 4 milliseconds and again 4 and then it will repeat till its burst time gets over. Now the waiting time, if we want to compute, waiting time of P1 is we need to sum up this time and this time. So while P2 and P3 were getting executed, P1 has been waiting. So 4 to 10 is the waiting time of P1. So it's 6 milliseconds. Now P2 has been waiting while this P1 was getting executed. So 4 milliseconds. But P3 has been waiting during this time period 0 to 7. Average waiting time is 5.67 milliseconds. Turnaround time is the time interval between the submission and the completion time. So here P1's turnaround time is 30, completion time is 30, arrival time is 0. P2's completion time is 7, arrival time is 0. P3's completion time is 10 and the arrival time is 0. So the difference between the submission and the completion time, average turnaround time is 15.67 milliseconds. Let us see one more problem. Here there are 4 processes given and the corresponding burst times are also listed. The time quantum is 4 milliseconds. The Gantt chart for the problem is given here. At time 0, P1 begins its execution and as the time quantum is 4 milliseconds, it will execute till 4. By the time 4, P1's burst time will get reduced to 4. Then comes P2. P2 will execute for 4 milliseconds and the chance is given to P3. It will execute for 2 milliseconds. It will end at 10. The chance is given to P4. It will end at 14. Now there are 2 processes remaining. Say P1 with a burst time, say 4 is remaining, and P2 with the burst time, say 3 is remaining. The chance is given to P1 now. So P1 will execute for 4 milliseconds. It will start at 14, it will end at 18. And P2, if it begins at 18, it will end at 21. Now calculating the waiting time for the processes, P1's waiting time is 10. The P1 waiting time, if we want to compute, we want to sum up this time and this time. So 4 to 14. It's 10. And P2's waiting time is 14. So here P2 is executing and here P2 is executing. So the remaining times we need to sum it up. That is 0 to 4 and then again 8 to 18. The waiting time is 14. Then P3, here P3 is executing. So 0 to 8, it has been waiting. So 8 milliseconds is the waiting time for P3. Then P4, it begins at 10, it will end at 14. So 0 to 10, it has been waiting. The waiting time of P4 is 10. Average waiting time is 10.5 milliseconds. Turnaround time is the time interval between the submission and the completion. P1's arrival is 0 and the completion is 18. 0 to 18 is 18. P2's arrival is 0. Completion is 21. Turnaround time is 21. P3 arrival time is 0. Completion time is 10. P4 arrival time is 0. Completion time is 14. So 0 to 14 is 14. Average turnaround time is 15.75 milliseconds. In this video, we have learnt about the round robin scheduling algorithm. Thank you.